Welcome everybody, also from my side. Thank you for choosing to follow this talk, whatever you're choosing to follow it from. And today I want to talk to you about Arturito, which is actually a story of a modern day Pinocchio, a Mexican Pinocchio that wanted to be a real boy. Now, this is not a very known story, and to be honest, I also didn't know it before this talk. And that's true, because it's not really a story. I came across this meme when I was preparing for the talk, and I thought it's a very nice intro to and joke to guide us into somewhat of a serious talk today. So I found it funny, but it's also a nice prelude into what are we actually going to talk about today. So most of you, I guess, know this guy, R2D2. It's a small robot that came to be the mascot or the face of our internal cloud provisioning tool. So our topic today is actually from prototype to production, or how did we go live with a tool that enabled us to do infrastructure as code in the cloud. So for those of you that don't know me, my name is Anastasija Efremovska, and today with my colleague Quiran Storey, we're gonna tell you what our path was with part of R2D2, because you may not know this well, but R2D2 has grown to be a very complex ecosystem. So it's not just one tool. So in order to talk about the things we know best, we're going to talk about the struggles we had with the Python application. So one of the major parts between R2D2 and the cloud. And we're going to guide you to all the modules together and tell you what are the struggles are that we survived. So that's as much for the disclaimer. But what are we actually going to talk about today? So we'll start with an intro, because I guess not everybody has used R2D2. So we're going to tell you what it is and shortly how it works. We're going to also tell you how it came to be, because it's been a while since this tool came to be. And then we're going to guide you through the proof of concept, or the war stories we luckily survived. Then we're also going to share some of the unexpected wins that we got while we were building R2D2, and we're going to give you a sneak peek behind the curtain of where are we heading. So whether you hate it or love it, I know you cannot stay indifferent. So sit back, relax, and follow the story. Okay, so for our lovely intro, what is R2D2? So R2D2, I know it's a nice acronym, and at Bol we really love our acronyms, but it actually stands for something. It means it's a reproducible resource deployment definition. In fact, it's an application for provisioning resources in the Google Cloud. So you can think of it as your one-stop shop for getting stuff up and running in the Google Cloud. So it is meant to be a self-service application, an application where developers can go provision things in the cloud on their own. And this tool also enables us to do infrastructure as code. All of these features are done in a supervised, secure, and reproducible manner. And remember this is really important. And since we've gotten involved with this project, we actually kind of became the face of, or the people behind R2D2. So you can get funny pictures like this you see on the right. Thanks, Leon. But that's part of the job, right? So how does it work? Users that want to get some resources in the cloud compose or put all their requests in a YAML file. And this YAML file is not much different from the Kubernetes YAML file you have. So once you have composed this file, let's say you want to have an application with a database, you send this to R2D2, which will parse, validate, and it will subsequently start creating all the resources in the Google Cloud. So this way you can get all sorts of resources, such as storage, pub subtopics and subscriptions, bare Kubernetes namespaces, databases, you name it, you can get it as long as it's available in the cloud. And this is all great, but by the time we get to where we are today with R2D2, there was quite a journey we all had to walk through. So for those of you that don't know, somewhere in 2016, the Cloud9 project started. And this was the project that was meant to launch bol.com into the cloud. So why did we need to go to the cloud? I mean, we do have the data center and it still services quite a lot of our applications. But we need to be aware in the last few years, we have really grown exponentially and enormously as a company. And with that has our IT landscape grown enormously. So our data center was getting too small for all the different microservices that kept popping up. The so-called NFR procedure we had that enabled developers to request resources from the data center. So if you had a new application that needed a database, you had to fill in this form, you had to predict how much data you will store in the database, how many requests and the speed would be, and then you would send it to your service engineer. So the service support engineers, they would go through the form eventually, and when they had the time, of course, there were quite a few people, you would get the resources you wanted. So of course, this was not fast enough and scalable, not just for the engineers that wanted to build applications, but also for the engineers that supported them. So at the end of the day, we really wanted to enable teams' autonomy and decrease the load on the SRTs by having the platform being managed by Google. But you would think, okay, you pick the cloud, we can go to the cloud. Why can't we just use the cloud directly? So why do we even need R2D2 to begin with? To answer this question, it all boils down actually to another question, and that is, should we have managed or unmanaged resources in the cloud? And this is not really an easy discussion. It's not something you can decide overnight. A lot of thinking and planning and discussing went into this. So to give a short glimpse of all the functional requirements that had to be taken into account, we can have a brief look at this table. So when we mean a managed solution, it's something that sits between you as a developer and the cloud, and something you need to use in between, versus unmanaged is you being a developer that can just log into a console and get all the things they need directly. Now, when you do changes to a managed solution, you can have a central desired state, or you can plan ahead what you need, and you can check and validate this. Whereas if you just go to the console of Google directly, you only get the actual state. So all the policy checking, all the accuracy, etc., would have to be done afterwards in an unmanaged solution. Then you can also think of what is the disaster or recovery. So if you have a managed solution, then and you do a change, a lot of things can break for your whole project, so it has a high reach. However, recovering is quite fast because things are somewhat standardized. Whereas if you have an unmanaged solution, let's say you break your database and that's contained to your database in the cloud, but recovering from that can be slow. The same counts for support. If you have a bit more managed solution, then it is a bit more standardized things that not just you, but also your support engineers have to deal with. So they're able to help you better. Whereas if you have an unstandardized way, and we know how much we love our autonomy at Bol, it is very likely to imagine a world where every team chose slightly different approach. So helping that sort of teams is really, really difficult. And one of the things that we also struggle with sometimes is the lead time. And lead time means what is the time from when a new product becomes available in Google, let's say, to the time we can use it. So in the managed solution, this is quite high, or it takes a long time till we wrap it and make it available. Whereas in Google, if you just go to the console, it's right there, right? And last but not least, we are still talking about 4 years ago, when out of the box tools did not exist to have a managed solution. Whereas for the unmanaged, those solutions existed, but were quite rudimentary. So this was more or less the train of thought that went on when decisions were made. So how was it built? So we decided that we needed a managed solution and we picked a cloud. Now you can also think of, why did we go for the Google Cloud? Well, Amazon is our direct competition. I wouldn't go there. So that's a bit understandable, I would say. And Azure 4 years ago was actually in the quite early stages. So as a cloud, they offered all their built-in stuff, but all the open source stuff were just starting to open up. So it was really not there with the tools we were used to using. And it was not like we decided right away that we're just going to build something on our own. There were some tools that were considered. You can think of Helm at the time, Google Deployment Manager, Terraform, etc., just to mention a few. But given the requirements, security, etc., that we had, nothing really satisfied our requirements. So what do you do when you cannot find something out there? You go and build it yourself. So go back to 2016 AD, and a team of 5 dedicated engineers was gathered to try and think of a proof of concept that can start to launch us into the cloud. So this team of engineers started with a small application, and they started building it out, given all the different concerns that started popping out, be it data, be it applications, monitoring, etc. So as things were growing, so the application started growing. So we needed to save some data. We needed to have different modular approaches. So the application kept growing and growing and growing. So now that the application was scaled, we had to also scale the humans, because it's easy to imagine with so many questions and different aspects of the cloud, which is a very complex topic, it's just not feasible to handle with 5 engineers. So what did we do? Well, we scaled the people, of course. So tech circles were formed where different groups of people would think on different topics. So be it provisioning, being big data, billing, security, whatever. So all this topic needed a separate attention. So now we had quite a few people, but we also still had one big monolith that was being built and maintained and developed as one big thing. So you do have a modular structure in mind, but the application is still one whole. So it was time to chop up that whole monolith apart. So chopping up the monolith brings us to somewhat today's state of affairs. I'm not sure how many of you have seen this architecture, but this is a really high overview of the whole ecosystem. And on this ecosystem, quite a few teams are working. So what most people see when they interact with R2D2 is our web interface built in Angular and maybe GitLab. And both these tools interact with the main application, which is a Python application through this API. But underneath, we have a bunch of Puppet modules that wrap up the different components. We have to keep the state of all your runs in a database. And we also have to have a tool for configuration management and for automating and reproducing all the changes. So that's why you can see Puppet or Terraform and even Kubernetes underneath on the right. So with such a big architecture, we also have a whole space of engineers that takes care of this complex bulk of things. So many of you maybe have talked already to some of these engineers, but nowadays we have 3 dedicated fleets that do different things for different domains. And I'm really glad that we have gotten so far, but getting there, especially for our team, since we started 2 years ago, there were quite a few struggles we had to go through. So to guide you through all the fun facts and war stories and our failures and wins, I give you my colleague Quiran, who is gonna give you the war stories.
Thank you, Anastasia. So yeah, so as Anastasia explained, we've got, yeah, she gave you a good overview of the entire architecture of R2D2, but as Team Hammer, we focus on specifically the Python component, so the sort of internal application that pulls in all the modules and exposes this. So this is sort of, so this part is really focused on the Python application, and as the title of the talk suggests, it's about prototype to production, and we really want to share like how this happened, how we went from this prototype and how it's running in production now, and some of the real war stories that we encountered along the way, the problems we had to overcome, and all of this while, the shop has to be open. We have to make sure the application's running. We don't have the slot to just be able to take it down, rebuild it over a month, and then put it live again. So how the progression of the application happened over the course of quite a few months. So first things first, R2D2 is a Python 3 application. So we're this Python application in a Java world. So that means like we don't get to rely on like all the cool stuff being built into the Axel framework. There is no such thing at the moment. And that means that there's a lot of self-discovery that's happening in terms of integrating into the IT landscape at Bol. So you think of logging, metrics, our OAuth2 integration with Google Identity Platform, our deployment, the database reprovisioning. This was all a lot of self-discovery and things we had to do ourselves. So starting with the first part of the journey down this proof of concept is a lot of people start using R2D2 and they ask like, why doesn't it have a REST API? But as with any proof of concept, they always start off with like, if you think about it, like scripts or like a CLI, so some bash script or a small Python script, and R2D2 was no different. It just happened to be a Docker image that you'd run as a CLI on your local machine, except this Docker image was quite large. It had Puppet, it had Terraform, and all its dependencies needed to provision in the cloud. And developers were using this locally to start getting going with our cloud infrastructure. And it was its starting point, really. And then as R2D2 needed to become available to a wider audience, it sort of moved into like MVP status, and then we needed to get it out to more people. And like the obvious choice is make it a web app. So we did that, and R2D2 got server-side rendering because I mean that's really easy. You throw some templating, bind it into your models, and off you go. And that worked for a long time. And as it started, more and more engineers started using it. We found that it started struggling a bit, and so as we progressed to a more mature framework or mature application where we are now, we had this really coupled web application. So our first thought was, well, we need to decouple this, and so what we did is we built out a REST API, and we moved our UI to Angular, so we were able to completely decouple the backend and front end, which was nice. And that meant that a month or two ago we were able to switch out the web framework that R2D2 was using with absolutely no impact on our consumers, which was really nice. But that we're not there yet. R2D2 is still evolving. We're still trying to mature it. So at the moment, we're writing our Open API spec by hand, which is terrible. We're hoping to switch with the new framework to be able to generate this from code, which would be lovely. And we're also going to be introducing service-to-service authentication, so to allow other services inside the Bol landscape to be able to communicate with the R2D2 API to allow more tooling to be built around it. I mean, often with proof of concepts, there's also a tendency to overcomplicate, and R2D2 was no different in this case. So we were using an immature Python web framework. I think it had the promise of async and all these things. It was a .6 release, so nowhere near to like a stable release. And that's what the web application was, the web app was built on, and we needed session management. It had no support for session management, so we needed to somehow make this work. So first, how do you do session management typically? Well, you need to store this information. So there's two ways to do it. So you either have server side, so you store all this information in the backend. You use cookies as sort of an identifier, and in our case we had Postgres, so that was good. But you also have the option to do it client side, so everything gets stored in the browser. Cookies are used, and you really rely on cookie signing to prevent tampering with this information. And we didn't have that available in this framework, so client side was obviously not a choice. And you'd think, well, we've got the server side solution, so we'll go with that. But that's not the case. enter Raft. So Raft is this consensus algorithm designed to be easily understood. It's sort of an alternative to Paxos, which is used in tools like Zookeeper. But yeah, we added this library that allowed us to share objects between our servers, which was all based on the Raft protocol. And with a few lines of code, we were able to add it to RTD2. It plugged into this we made it plug into this framework we were using. We were able to then store session information, which was great, and we had no backends to maintain. So I mean, that was even better. So this is like really a win-win situation. And then the issues arrived. So the cluster would lose consensus because we had built this into our own application. We had no tooling to manage leader election. Obviously, RTD2 would have downtime, and then it would require us to do these rolling restarts throughout the week with the RTD2 server. So we looked at that and we said no, and we threw that out the window. Said goodbye to Raft, and decided to just keep it simple. We implemented cookie signing for this Python framework we're using, and to date we've had no issues. And sort of just a reminder, like keeping it simple is always important, and try not to overcomplicate things. The other thing with proof of concept is security vulnerabilities are definitely not uncommon. So. And RTD2, absolutely no difference here either. And there's honestly nothing as frightening as getting to work in the morning to find a critical remote code execution ticket in your Jira queue. And what's worse with us was we had Python pickles involved. So first, a little backstory for those of you not familiar with Python pickles. It's a library that allows you to serialize and deserialize objects in Python. It ships with the standard library. It's I mean, if I give you an example, you can take you have some class, it has attributes, you instantiate this class, you have this object, and you say, well, I'm going to put it through this pickle library. I serialize it into sort of a byte stream, send it over a TCP IP connection to a server somewhere else in the world. You deserialize it, and you end up with an object again, which is fantastic. The object's not necessarily going to be, well, it won't be at the same memory allocation, but it will definitely, you'll have this object on the other side. So that sounds kind of cool. Except if you go read the docs, the pickle module is not secure, and only unpickled data you trust. So with that in mind, back to our remote code execution vulnerability. RTD2 was using pickles to store well, we were pickling user preference data into cookies. So that means every time you come to RTD2, you sort of configure the way you wanted to use it. There was sort of preferences that were available for tweaking. And this information was stored in cookies in the browser. And these were objects, so the pickle library was used. So if you look at this code snippet, we would this stuff would be stored as base64 encoded data in the cookie. We would decode this data and then pass it through the pickle library to end up with an object on the other side. So you ask yourself, why is this bad? Well, a simple Google reveals that it's really easy to do remote code execution with pickles. And if you look at the example here, you can create a class which in this case does a system call, and you can encode this data as base64 and send it on its way, and the Python interpreter on the other side would then load this up and execute this code without the maintainer of the code having to call some specific attribute or method on the actual object. This code fires whether you like it or not. So you can think of like an RMRF or any kind of like seriously malicious act can be done quite easily through this. And it took an engineer on the team to put up a proof of concept, and he was able to place files on the RTD2 servers in production in the temp directories, nothing malicious at least. And what's worse is like RTD2 runs as root, so it has an enormous amount of privileges because of what it needs to do. And on top of that, RTD2 has these pseudo permissions to our cloud. And yeah, this is really like a wake-up call of like these where you need to be careful with these proof of concepts and the things that can happen along the way. And it was not a great place to be in, but we fixed this issue, and the person who reported this got lots of bug bounty from security. The next step in our sort of journey was the database. in the beginning, RTD2 wasn't doing a lot when it was just on everyone's machines for the developers starting out. So it was mostly tracking files, and there's sort of a SQLite database was added. This database had no foreign keys. We had no migrations, and for the most part, it was schemaless, thanks to pickles again. But sort of as RTD2 developed and matured or progressed and became sort of its MVP status, and we had this web application, we moved to Postgres. We added relationships to our database. I mean, the basics, I guess. We added PuppetDB as another backend for the Puppet orchestrator. We introduced schema migrations, so that meant that new engineers joining the RTD2 project would be able to get working straight away without having to rely on finding the latest schema from another developer. We just handled it with the code, or shipped it with the revisions of the code. But we hit the pickles again, and oh my god, pickles in our database. And yeah, so that was a pain, and we ended up with all these tickets that like pickles must die. We need to get rid of them. But let me explain why this was such a problem. So first things first, if you pickle, the way the data was being pickled is this byte stream. So if it gets stored in Postgres, ultimately it's just a byte array. So what's really bad is that if you want to query data out of the database, you can't actually use SQL because it's meaningless. And secondly, so you need this a Python interpreter to be able to connect to your database, pull out the data, and then deserialize it. And then on top of that, you're not querying it; you're actually selecting all the data out the database and then doing your queries inside of Python. Really, not a great place to be in. But the other issue that we ran into was that unlike our cookie preferences, which was a really simple model, the model inside of RTD2, or the models inside of RTD2 are quite complex. And if you look at the example I have on the screen here, is that you have this class model that has a type that has this enum that's referenced from another Python module. So now think of the position where you serialize this object into a pickle, you write it to the database, and now in your next code revision, you modify the enum, you give it a different name, the attributes on the enum changes, or it gets placed into a different module, so the import paths change all of a sudden. Now you read historic data out of the database, and the pickle library tries to deserialize this and realizes, but the enum doesn't exist anymore in your code base, so Python throws stack traces, and effectively you crash, and everyone's unhappy. And we actually found ourselves in this position. We had tied our database to the code base and vice versa. And there was a point where we were trying to get a simple bug fix out, and we couldn't actually roll the code forward or backwards. We had really tied ourselves down to a revision of both our database and code base. And what was horrible is that no developer wants to be in this position. So we had to tell everyone that feature development had to be halted, and we needed to fix this as soon as possible. There was just simply no way out of this. Luckily, we got through that. We were able to migrate all the with lots of Python code and a bit of SQL. We were able to get it from pickles into Postgres native data type. So I'm glad to say we have no more pickles in our database. And on top of that, our database is actually now part of the bulk provisioning tooling within Bolt. I think it's the first database that is part of that. And I guess, out of all of this, the biggest takeaway here is the fine line we walk between balancing innovation speed and technical debt. And in our case, we got a lot done in the early years. The innovation speed was really fast. But the technical debt that we piled up along the way caught up with us, and there was a point where we just couldn't do any more innovation. We'd painted ourselves into a corner, and we had to pay back that technical debt. And it's always a constant reminder to keep an eye on the sort of the innovation speed we do, or the innovation speed we're working at, and the amount of technical debt that we're adding while we're incurring while we're on this path. Those are my war stories from our team. With that, I'm going to hand you back to my colleague Anastasija, who will tell you about some of the unexpected wins we had along the way.
Yes. So thank you, Quiran. I know so far this may seem like a very horror story, but not everything is so grim. So first, with the things we are really, really proud of is that throughout all this mess and growing and fixing, etc., we actually managed to get our R2D2 Postgres database to be the first database in Bol to be auto-reprovisioned. So that's something we're really, really proud of. Another thing we all have to keep in mind is that the time we moved to cloud, and one of the reasons why we moved is that Hadoop, one of our big data storage systems, were being phased out, was being end of life. So we went live and running with a POC or MVP already, and we were serving some projects in the cloud already back then. So we were really building the plane while trying to fly it, and indeed we all had a piece, not just the provisioning teams, but also the feature teams. And let me tell you, that's really, really difficult job. Another thing we just recently built, I think it was November when we released our first stable API. So before that, every Monday, all changes would come and every project would have to update. And that was really horrible. We know that. But keep in mind, even though current releases are every 2 months, it's not all our fault. Because if you think of the architecture again, it's a very volatile stack we are working on top of. So you have GCP, Kubernetes, Puppet, Terraform, multi-team contributions for different modules. And all of these things break underneath. All of these are going so fast that it's really difficult to really keep the whole thing stable. So think of GCP's BigQuery API. It was like breaking a few times already by changing some of the API fields. And that is something that when you look from the outside may seem like, oh, R2D2 is breaking, but that's not always the case. So in trying to fix this, we even made our own tool to manage the stable releases and all the breaking changes. We call this C3PO, and this tool is based on conventional commits. We want to thank Team Mirage for giving us the inspiration. And with this tool, we enable the developers or contributors to R2D2 and all the modules to be able to version their modules separately. And us on the other end are able to keep one stable API exposed to the end users on the outside. And to put the money where my mouth is, let's talk about numbers. So from this week, we had 1,390 projects that are running in the cloud, of which around 600 are on Pro. We have 133 different OPEX registered teams, and we've had around 500,000 R2D2 executions so far. And we have, of course, 3 stable API releases and another one coming soon. And another thing to kind of end up this talk with is where are we heading? And I'm hoping some of the questions I see popping up will be answered already. So now we have a whole space of engineers. We have this product that's no longer an MVP. We have a product owner. So where are we going? So we managed to do this very formal definition of what is R2D2 trying to solve. If you try to read it carefully, it's everything we talked about so far. So we want Bol employees to innovate quickly, so they would use R2D2 to allow them to manage resources on their own in a simple, fast way. But we have to do this in a very secure, supervised, and standardized way of working, unlike all the other tools out there. So this is all great, but we have still a long way to go. One of the things that we really have been paying attention to recently is what is our user group? What are the different personas and what is their feedback? What do they really miss? So far, I think we treated our users as either contributors or users, which is far from the truth. Actually, we have very different usage group. So you have the contributor on the leftmost that they really strive for stability. They don't like too many changes and they really want their things to run. And on the rightmost, you have the business user. These are not per se IT tech savvy people, but they really need to use the cloud for data, for example. And all they really want to do is just do some templating. They will never have to or need to learn Kubernetes in its depth. But then in between, you have the basic users or the advanced users that can understand this, but maybe they don't have the time to do everything. So those are very different and somewhat conflicting requirements we are facing. And we did some interviews with our stakeholder groups. We've gathered their feedback, and now we're trying to gather stories and try to put that on our roadmap to see how to best cater to all of them. One of the things we kind of hinted on is the service-to-service communication. So having R2D2 have a complete REST API. So far, we can only allow users to access the API using a user token. But in order to enable other teams to build on top of it, we need to have a proper service API. And for that, we need to still introduce the service tokens. So one candidate or example for this is the service software parade that really gets some valuable data from R2D2, and we want to help tools like that innovate with us. So this is just a small sneak peek that we as a team or a platform will do, but we are by no far done. So there are so many questions left we still need to answer together with our users. And that is, are we still on the right path with R2D2? This has been happening 4 years ago. Are all the decisions still valid? Are there any industry and tools that have changed and that have grown that we could maybe use out of the box? So, and also, how do we onboard new engineers? Who does the support? Shall we even be building R2D2 by ourselves, right? How self-service is really R2D2? Is it really as user-friendly as we think it is? And does every engineer need to know everything there is about Kubernetes or the cloud or what have you? And also, do we need cloud SRTs? I mean, these are all questions we ask ourselves or our users ask us. And there are initiatives that already start to tackle some of these, such as the SREs or support. But we are still not there yet. So these are the questions we could think of. But I know that many of you also have some questions. So this was our talk. Now I would like to ask you to join us into a Q&A session. Thank you. Yes.
Deepak, I think you muted.
You muted, Deepak.
Sorry. Thank you. Thanks a lot for the presentation. It's really beautifully and clearly put. I can see in the questionnaire, people really like the presentation. There are cheers to Hammer team. It gives about the history and also insights on how difficult it is to build such a tool. Let me try to go through now Q&A and find some of the questions. Maybe you already answered them. Of course, the question is, why Python application instead of a Java? Are we also going to continue with Python or build it in Java?
Yeah, that's a nice question. And if you think back that it all started with a POC, and when you think of what are the engineers to best POC infrastructure as code tool, well, you're gonna take infrastructure engineers. And that sort of engineers don't do their scripts in Java. They would mainly use either Bash or Puppet or Python. And Python was still kind of high enough language to be picked up by other engineers. Now
there's also a question, sorry.
Yeah.
There's also a question about Go or Rust.
Yeah. Maybe Quiran wants to talk about Rust.
Yeah, I think the Rust is someone trying to troll me because of my love of Rust, but no, I don't think Rust is the right language for this. So I still think like Python is a good language for the sort of application that the class of application that's being built. But I guess what I try to get across from my points in the slide is like Python's also a dangerous tool if you don't treat it rightly. Like it's easy to shoot yourself in the foot, if that makes sense. So you don't have all the compiler checks that are there for you. So you need to, like, it's really easy to just throw objects around. It's really easy to just throw dictionaries around. Like, so you need to also treat it sort of with like respect. If you're going to, it allows you to take shortcuts. So you need to be careful with that. So I don't think it's like, it's just, unlike other languages, you can't. It doesn't let you get away with this stuff. So that's also on the developers not to do that in Python. But I don't think that Python is a bad tool or language for this, especially given the engineers that started this project. Like it's the right tool. I think maybe with the amount of engineering, like Go development happening inside of Bol, maybe Go could also be a good candidate now. But if you look at the engineers that started the project and the time that when it was built, I think Python was the logical choice.
Yeah, so there's a question also related to, for the future, would it be Java? Because there are more engineers who have knowledge of the Java within the organization.
So the future of R2D2. So at the moment, I think it started like late December. At the moment, we, as a team, we're driving or trying to coordinate this thing to figure out what the future of R2D2 will be. So are we still on the right track as a company? If you like consider the position we went to the cloud with a couple of years ago and the position the industry has taken since then. So what are other companies doing in this space? And so we've actually not even focused at language at the moment, just like how do you address infrastructure as code for cloud environments? And you're seeing amazing things come out of different companies. So I need to get right now. It's Shopify. That's right. Shopify are using Kubernetes to spin up their infrastructure. So if you look at like you create a deployment definition inside of Kubernetes, you could create a custom resource definition which says I want a bucket, and you can do that through Kubernetes. So you building CRDs and operators inside of Kubernetes, and that's an approach that's happening. Spotify, I think now, because the names are so close. They're also busy open sourcing a tool that they're using to do all of this. So we really want to focus, like that's why that question, like, are we still on the right track? We want to look and see that are we going? Is Bol still on the right trajectory to put us 5 years down the, like if we look 5 years down the line, are we still, will we be in a good position? So we want to reevaluate the thing as a whole and then go and say, okay, what's the right language for it? So we don't really want to make a language choice just yet. And we're sharing this information as it's developing, so it's still early days.
With that, actually, you covered also a couple of other questions where is there an out-of-the-box solution available? And if not, could we sell and outsource our solution? Perhaps you want to put a bit more light on the second question.
So the open sourcing our solution. So yeah, I think at the moment there's quite a bit of logic inside of R2D2 that's specific to Bol. So a lot of like how, especially if you look at how our hybrid setups are, how we communicate, how we link the cloud and the data center together, and specifically because we're using Puppet in the data center. So I think if we could remove some of that logic and provide a more like policy-based approach to provide sort of policy input to R2D2 or facilitate that, then we could at least potentially open source it. But as it stands right now, it's really focused on Bol's IT landscape.
Thank you. I'm looking for next question. Yeah, given the danger of spinning up our tooling, especially with respect to security, what's the next step in R2D2? Any plans to move to our standard tooling now, 7 years later? But I think you covered it in a way.
Yeah, so we are. I think what we're really looking at is to make sure we're on the right track. The other thing in our solution that we like, so Anastasija spoke about like the users the end users that R2D2 has, and now we have a far clearer idea. We now an actual product team. We've got a PO, which is fantastic. So it's helping to drive all of this. We're looking at like if you look at like how specifically on the part of standardized tooling, every engineer that joins Bol has to learn another internal tool, and like if you can find more open source tools, it also helps engineers join and get started a lot faster than having to first learn internal tools. So yeah, this all adds to the conversation around where we're going in the future.
Yeah. And one last thing I want to add to that before we close, I guess, is that we are from what we've seen, by far, we are not the only company that has decided to build their own tool. Actually, all the tools you see spawning up or mushrooming nowadays by Spotify or Pulumi or whatever it's the name of the other product, they were all started as internal tools because nothing was out there on the market that could satisfy the needs. So I think we'll see. Yeah.
Yeah. Thanks a lot. I really enjoyed the presentation.